Science Galaxy. Welcome to our channel Science Galaxy, where we learn science in simple ways. Don't forget to like, subscribe and share the video.
Now we are going to start about graphs. We would learn about certain graphs. We need to learn about three types of graph, that is distance time graph, velocity time graph and the acceleration time graph. Let's start with distance time graph or position time graph. In position time graph, we would consider three cases: object at rest, object with uniform velocity. Now let us discuss about the object at rest. If the object at rest, that means it does not changes its position. If it does not change its position, for example, the object was initially at 25 centimeter and now the object at every time interval, the object is at the same distance 25. So if the object is stationary, it does not move, then the distance time graph would be straight line parallel to the time axis. This is the average, this is the object at rest, and if the object is at rest, definitely its velocity as well as acceleration would be zero. If object is not moving, how can it have any velocity? And if velocity is zero, velocity is not changing also, velocity was initially zero, finally also zero, so acceleration would also be zero. Second case is when object is covering equal distances in equal intervals of time. That means object is covering speed, object is been having uniform velocity. It means that object is moving with a uniform velocity. Then its graph would be straight line passing through origin if initially it was at its origin. But initially if it was at 25 centimeter, its graph could be like this. Starting from 25, its graph could be like this also. But if it had uniform velocity, if it is moving, if it is not at rest, if it is at rest, then the graph would be parallel to time axis, a straight line. And if it is not at rest, it would be a straight line, oblique straight line. If initially at origin, reference point is origin, then the line will pass through origin, a straight line passing through origin. If the object is moving in the negative direction, if the object is moving in the negative direction, means this is the origin. It started first moving like this and then it came back to zero, and now it is moving in the negative direction. If it is moving in negative direction, then the graph would be downwards. In negative direction, but with constant negative velocity. With a constant velocity, then the acceleration would be zero. If not the uniform velocity, we can think about the graph. If the velocity is not constant, the graph would be a curve. The graph could be a curve if it is not moving with a constant velocity. Like this. Displacement time. If it is not moving with constant speed, if it is increasing its speed, then its graph would be like this, curved. And if it is reducing its speed, non-uniform speed, the graph would be like this. This is accelerated motion. Speed is increasing. And it is retarded motion. Speed is decreasing. Now consider this graph. This is distance time graph. Here is our position, here is our time. The object first moved with a constant velocity. Then it came to rest. Then it moved in the negative direction. And then moved to the opposite direction to the starting point. Means the object started like this. Object started from this point, moved further, came to rest at this point, and then moved in the negative direction, came to the starting point. Here it is at the starting point, and then covered a negative distance. Means the object first moved with the uniform velocity further, then it came to rest, and then it moved in the negative direction, came to the starting point, and then moved further in the negative side. Now we need to remember one thing about distance time graph. The slope of distance time graph gives us the velocity. Slope. What is meant by slope? We would discuss it. Slope of dt, position time graph, is equal to velocity. For example, consider this graph. This is distance time graph, displacement time graph. And what is the slope? For finding slope, choose any 2 points. We have chosen these 2 points. Now let this point be T1, let this point to be T2. At this point, let the displacement would be x1, and at this point let the displacement would be x2. So during these 2 points, how much distance would have been covered? Distance would have been covered x2 minus x1. So this distance would be x2 minus x1. This is x2, this is x1. So what is this? This is x2 minus x1. Similarly, this is time t2, this is time t1, this is t2 minus t1. Slope. What is the slope? Slope is this upon this, perpendicular upon base. This upon this is a slope. So slope of distance time graph or displacement time graph or position time graph gives us the velocity. What is the slope? This part means x2 minus x1 upon this part means t2 minus t1. So velocity would be equal to x2 minus x1 upon t2 minus t1. What is this? This is distance time graph. One more thing, if there is one more graph like this, it also has a uniform velocity. Which one would have more velocity? Definitely this would have greater velocity because its slope is greater. If there is some confusion, just draw a line parallel to the time axis. If we will draw a line like this, at this particular t1 time, this is object A, this is object B. Object A covered x1 distance, and at this time B covered this much distance. Obviously this distance is greater than this distance, so A in the same interval of time covered greater distance than B. This means the velocity of B is greater than A because it has greater slope. So what does the slope of distance time graph give? The slope of distance time graph is equal to the velocity of the graph. Now let's move on further to velocity time graphs. We would discuss about velocity time graph. First is with with constant velocity. Constant velocity means zero acceleration. In this case, the distance time graph was like this. If it moved with constant velocity, the distance time graph was like this. Constant velocity means it is regularly moving at 2 meters per second. It is not increasing its speed, but it is moving. It is not at rest. Don't confuse this graph with this graph. Here distance is not changing. If the position is not changing, the object is at rest. And this graph means velocity is not changing, means the object is moving but with a constant velocity. The object is covering equal distances in equal intervals of time. Here the acceleration is zero because the object is moving with constant velocity. If the object is moving with increasing velocity means it is accelerating, but the acceleration is uniform, means it is increasing by 2 meters per second every second. The case we discussed, first the velocity is 20 meters per second, then 22 meters per second, then 24 meters per second. Its velocity is increasing, but by equal amount in equal intervals of time, means uniformly accelerating. Then the velocity time graph would be a straight line, oblique straight line, passing through origin if its velocity is initially zero. And if its initial velocity is not zero, its graph would be like this. If its initial velocity is, let us say u, initial velocity is u, not zero, then the graph would not start from origin, rather it would start from the point u. If the object is moving with velocity decreasing, means it is retarding, the object is retarding. Please don't confuse this graph with this graph. If the velocity time graph is like this, coming downwards, it means velocity is decreasing, and it means that it is going in the negative direction. It is returning to the certain point. So if velocity is negative, if the graph is like this, then the velocity is decreasing or it is facing retardation. Let us consider this case. First, the velocity increases, means it is accelerated motion. Then velocity decreases, it is a retarding motion. Then it moves with a constant velocity. Constant velocity does not mean that object is at rest. It just means that the object is now moving with constant velocity. It is not increasing or decreasing its velocity. Also remember, the slope of dt graph gives velocity, while the slope of vt graph gives acceleration. The slope of velocity time graph gives us the acceleration, while the area under vt graph gives us displacement. Slope of vt graph gives acceleration and area under vt graph gives us the displacement. Consider this velocity time graph. First, the velocity increases uniform acceleration, then it moves but with a constant velocity. Now it is moving with a uniform velocity 2 meters per second. It is not increasing its velocity. 2 meters per second, 2 meters per second, 2 meters per second. It is not increasing its velocity during this time. Then it starts to increase its velocity. Again the acceleration becomes zero here because it is not increasing its velocity. It is moving with uniform velocity here. Then it decreases the velocity, retardation. Then uniform acceleration. Then it increases the speed. So this graph tells us this. For uniformly accelerated motion, if the initial velocity is not zero, initial velocity is u, the graph would be a straight line but not passing through origin, because now the initial velocity is not zero, rather it would start from this point. And it would be a straight line Also, the slope of this line would give acceleration. How would we find out the acceleration? We choose these 2 points. Now we are going to choose these 2 points. Initial velocity is u, means this part is u. Final velocity is v, means this part is v. That means this part is v minus u. Also, we know the slope of this line. Slope, what does we mean by slope? Slope means this part perpendicular upon base. This part upon this part is the slope. This part is equal to v minus u. This part is equal to t. So a is equal to v minus u upon t, or at is equal to v minus u, or v is equal to u plus at. This is first equation. We need to remember it carefully. V is equal to u plus at. Discuss the equations of motion. Now first let us draw a graph for a uniformly accelerated motion, a VT graph. Velocity time graph. It would be an oblique straight line. Here it does not passes through origin. It does not passes through origin because the initial velocity is not equal to 0. Rather, initial velocity is equal to u. Initial velocity is u and the object is moving with uniform accelerated motion. Also, we know the slope of velocity time graph is equal to acceleration. How can we draw the slope? How can we find out the slope? For finding out the slope, we need to draw any 2 points. Consider these 2 points. Now we know we need to find out the slope. How can we find out the slope of this graph? The slope is equal to this part upon this part. So now the slope is equal to this part upon this part, and if this is u, then BC part is also equal to u. And if this part is equal to v, initial velocity was u, so this is also equal to u, while this part is v, and so this part is also v. The part AB is v minus u. This part is equal to v minus u. And now we need to find the slope. Slope is equal to this part upon this part. That means v minus u upon t. Acceleration is equal to slope. Slope means choose any 2 point, draw a triangle, find the perpendicular, find the base. So perpendicular upon base is equal to acceleration. Slope is equal to acceleration. So A is equal to v minus u upon t. These two will get multiplied. We will get the equation v is equal to u plus at. This is the first equation of motion. This we need to remember, that final velocity is equal to initial velocity plus acceleration into time. Now another thing is distance is equal to average velocity into time. So distance is equal to average velocity into time. And what is the average velocity? Average velocity is the average of initial and final velocities. That means v plus u upon t. Average velocity will be equal to v plus u upon t. And distance is equal to average velocity into time, that is v plus u upon 2 into t. This is also considered as an equation of motion. Distance is equal to v plus u upon 2 into t. Another thing we need to remember is the area under VT graph gives us the displacement. So the area under VT graph gives us the displacement. Now, the area of the given figure would mean the area of this triangle plus the area of this rectangle. This triangle, the area of triangle is equal to half base into height. Here base is equal to t and height is equal to v minus u. So, the dimensions of triangles are v minus u and t, while the dimensions of this rectangle is a t and u. We can say that the length of this rectangle is u and its breadth is t. So area of rectangle plus area of triangle would mean UT plus area of triangle was equal to half base into height. Half, what is base? Base is here T and height is V minus U. So the area is equal to half V minus U into T plus U into T, area of rectangle. So area gives us displacement ut plus half v minus u into t gives us delta x. But we have already said that v is equal to u plus at. We have already derived this equation, and this equation will be used in deriving second equation as well as the third equation. So we would write, in place of v, we would write u plus at, because v was equal to u plus at as derived in the first equation. U plus at minus u and u cancelled out. Ut plus half at square is equal to displacement. Delta x means x2 minus x1. If initial position is x1, final position is x2, then x2 minus x1 is equal to ut plus half at square, or we can say x2 is equal to x1 plus ut plus half at square. Also we need area. We know area of VT graph, area under VT graph is equal to displacement, but now we are not considering it in a triangle and a rectangle. We are rather considering it to be a trapezium with two parallel sides and two non-parallel sides. The area of trapezium equal to half sum of parallel side. Parallel side are V and U. Half into sum of parallel side and into height. Height is equal to T. So half sum of parallel side means V plus U and into height means T. Area of trapezium is equal to displacement. What is area of trapezium? Half sum of parallel side into height. But from first equation we know V is equal to U plus AT. Now we would write, if V is equal to U plus AT, that means T is equal to V minus U upon A. We have just find out the value of T from the first equation. First equation is also called fundamental equation because it is being used for finding out second as well as third equation. So T is equal to V minus U upon A. Delta x was here equal to sum of parallel side means V plus U and into T. T was here height. This T will be equal to V minus U upon A as derived from first equation. So the displacement would be equal to 1 by 2 V plus U into V minus U upon A. V plus U into V minus U is equal to V square minus U square. Here is a small identity where A plus B into A minus B is equal to A square minus B square. So delta x will come out to be V square minus U square upon 2A. Here 2A into delta x is equal to V square minus U square, or delta x, in place of delta x we can write x2 minus x1. V square is equal to U square plus 2A x2 minus x1. Now we need to remember all these equations. First was V is equal to U plus AT. Second was distance was equal to V plus U upon 2 into T. Third was displacement x2 minus x1 was equal to ut plus half at square. X2 minus x1 was the displacement, which was equal to ut plus half at square. Third equation which we have derived now is V square is equal to U square plus 2A into displacement. Now let us try one question. Car moves with 10 meter per second, accelerates for 4 seconds at the rate of 4 meter per second square. So the car initially was moving at the velocity 10 meter per second. This is U. Initial velocity is 10 meter per second. It accelerated for 4 seconds. Time is 4 seconds at the rate. This is acceleration. Meter per second square is the unit of acceleration. So this is acceleration. Acceleration is equal to 4 meter per second square. We need to find the distance. We would first write value of u was 10 meter per second, acceleration 4 meter per second square, time was 4 seconds. We needed to find delta x, means displacement. We know from third equation delta x. Second equation was delta x, or displacement, was equal to ut plus half at square. In place of u, we would write 10 meter per second. Time, we would return all the values, and the distance or displacement would come out to be 72 meters. Next question is, a stone is dropped from 80 meter, strikes the ground with 40 meter per second. We need to find the acceleration. So here displacement is 80 meters. Displacement is 80 meters because the length of the path covered by stone is 80 meter. And here initial velocity is equal to 0 because initially the stone was at rest. Now finally it moved with 40 meter per second speed. So final velocity is 40. And we need to find out the acceleration. We would use the equation v square is equal to u square plus 2a into displacement. Here we will write the value of v to be 40 meter per second. U, initial velocity was 0 because initially the stone was at rest when it fell from a height 80 meters, and the displacement would be equal to 80 meters. From this we could easily find out the acceleration, which would come out to be 10 meter per second square. We would discuss it further that acceleration due to earth gravitation is 10 meter per second square only, irrespective of the mass of object. The attraction of earth, the earth attracts every body with this acceleration only. We would discuss it in the topic freefall. Then that if an object is freely falling under the earth gravitation, then acceleration would always come out to be 10 meter per second square. This is an approx value. Actual value is 9.8 meter per second square. Now another question. Here we are given with a xt graph, means displacement time graph, and it is not a straight line, means the object is not covering equal distances in equal interval of time. It is not having uniform acceleration. It is not having a uniform velocity. Xt graph is not a straight line. Had it been a straight line, it meant that it means that object is not covering equal distances in equal intervals of time. That means it is not moving with uniform velocity. Rather, it is an accelerated motion where the velocity is itself increasing. If the curve is like this, it means uniform acceleration. While if the graph is downwards like this, then it is retardation, means negative acceleration. Now we need to find out the average velocity from 5 to 10 seconds, between 5 seconds to 10 seconds. Here from 5 to 10 seconds, the time is 5 to 10 means 5 seconds, and the displacement is 500 to 1000 means 500 to 1000. How many meters? 500 meters. So the velocity will come out to be 500 meter upon 5 second, that is 100 meter per second. We just need to find out how much displacement it covered from 5 to 10 seconds. That would be 500 to 1000. We would think he was initially at 500 meter. He went through 1000 meters. So how much distance he covered? He covered 500 meters. Now another is from 10 seconds to 20 seconds. 10 seconds to 20 seconds. How much distance he covered from 10 seconds to 20 seconds? 1000 meter to 2500 meter. He covered 1500 meter distance in how much time? In 10 seconds. Then there is another question from 0 to 20 seconds. 0 to 20 seconds, how much distance he covered? From 0 to 2500, he covered 2500 meters. And in how much time? In 20 seconds. Here we see that average velocity will not come out to be 0. It means that velocity is not uniform, rather it is an accelerated motion. Now we are going to study about free fall. Free fall is when the object falls under earth gravitation without any external force. Here now let us try one question. Rock is dropped from 80 meters. How long does it take to reach the ground? Here displacement delta x. The displacement is 80 meters. How long does it take? That means time is equal to question mark to reach the ground. When the stone is initially dropped, u will be 0 meter per second. Initially, it would have 0 meter per second velocity. It is falling from 80 meters. We need to find time. We know about the formula 2a delta x is equal to 2a into displacement is equal to v square minus u square. Here 2 acceleration, because the object is falling freely under gravitational force, gravity is equal to plus 10 meter per second square into delta x. What is delta x? Delta x is 80 is equal to v square. We do not know about v square minus u square. U is 0. From here we will come out to be 40. Under root 1600, that would be 40. Then we would use the formula v is equal to u plus 80. Here v is 40, u is 0, acceleration is 10, and time we need to calculate. 40 is equal to 10t, time is equal to 4 seconds. Let us try one more question. A ball is thrown vertically with velocity 20 meter per second from 25 meter height of a building. How long ball take before reaching the ground? How much high will the ball rise? So the question is that there is a building. Let us consider the building to be AB, and the building is 25 meters tall. So the building is 25 meters tall. Building is 25 meters tall, and a ball is thrown from this point B. Ball is thrown from this point B, and then the ball returns to the point F. We need to find how long the ball take before reaching the ground. How much time the ball take to reach the ground? The ball will first rise from a point B to another point C because it is thrown from point B, and the ball will then return. So we need to find out the time taken during this procedure. Initially at this point B, from point B to C, ball was initially thrown with 20 meter per second. At this point the velocity became 0. Velocity became 0 at this point. From this point to this point, the gravity is 10 meter per second square, but the ball is rising. If the ball is rising, the gravity would be taken as negative because the work is done against gravity. So G is minus 10 meter per second square. Now we would apply a formula V is equal to U plus AT, first equation which we derived from the graph. And from here the time would come out to be 2 seconds because v is known to us, u is known to us, acceleration is known to us, and we needed to calculate the time. Then the distance CB would be equal to, again from B to C, the distance will be equal to S is equal to UT plus half AT square. S is equal to UT plus half AT square. Here U is known to us, time is also known to us, which we calculated, plus half, acceleration is minus 10 into 2 square. 40 minus 20, the displacement would come out to be 20 meters. So the distance CB is 20 meters. Now we know this distance is 20 meters. Now we can do two things. Either we can say that from D to F the total distance is 45 meters, because this distance is 20 and this distance is 25 meters. So from this point to this point the distance is 45 meters. At point D, initial velocity is 0, distance is 45 meters. Acceleration, because the object is coming down, the acceleration is 10 meters per second square in the positive. Now we would apply S is equal to UT plus half AT square. S is known, U is known, half A. T we needed to calculate. From here time can be calculated 3 seconds. So the object when rise from this point to this point takes 4 seconds, and from this point to this point takes another 3 seconds. So total time taken would be 5 seconds. Now the second part is how much high the ball will rise. How much high? The ball was initially at B. How much height will it rise? It will rise through a distance of 20 meters more, because we already found out the distance CB to be 20 meters.
Thanks for watching the video. I hope you like it. Don't forget to like, share, comment and subscribe.